Hi everyone, Thibaut here. And this is What's New in Octave, your monthly rendezvous with Octave, the edge-to-cloud data orchestration IoT platform by Sierra Wireless. And today, for the last session before our August break, so don't worry, we'll be back in September, the team will give you an update on the most recent features deployed recently in Octave. If you're not familiar with Octave yet, I would recommend you to check out the videos of the previous sessions on Sierra Wireless YouTube channel, as well as our Octave tutorial playlist. So as always, this interactive developer session is your opportunity to interact with the presenters and get your questions answered live, either during the session or during the ending Q&A part. As usual, the session is recorded and will be added to our YouTube channel in the coming hours. If you are watching this session on YouTube, check in the description below for the link to register for the live session so that you can interact with the presenters next time. Now, before we start today, I'd like to renew an offer I made already here a few months ago. We are definitely interested in promoting your IoT applications that you are developed with Octave. So if you are interested in sharing with us and the community your experience with Octave, in a particular use case you are developing or you already developed for your company, and give it a bit of promotion, please reach out to me. You will find my contact at the end of the session. All right, so as you know now, all Octave developer sessions are co-animated by members of Octave development team, and this one is no exception. So it's a pleasure to welcome for the second time David Bonnet. Hi, David. David is senior staff engineer front-end development in Octave team at Sierra Wireless. Meaning that David and his team are responsible for the development of Octave user interface. So I'm sure you will have plenty of questions for David today, either on the new features David will present or on Octave UI in general. Also today, as you can see, we have another presenter you know quite well already, I'm sure. I've named Augustin Mont-Saint-Jean. Hi, Augustin.
Hello, everyone.
Augustin is a senior manager and Octave solution architect at Sierra Wireless. So feel free to prepare your best questions for Augustin as well. All right, without further ado, let's see what's on the agenda for today.
Thank you, Thibaut. Okay, so let's start with something that is not really related to your solution, which are icons. Then I'd like to talk about cryptographic functions, which appeared on Cloud Actions and Tasks. And then we made some improvements regarding some of the widgets, and in particular in the device imports. And following the release of the 3.2, we now support 2 UARTs with the USP service. We're going to see a little bit what this looks like. So new icons. When you first create, when you create an account on Octave for the first time, you're greeted with this chart that explains what the different entities, how the different entities relate to each other. So it's a new chart, and you see also new icons. You might have noticed that there are 2 categories of icons, the icons for the device and the icons for the cloud. And so we designed them as such so that you can easily distinguish the context, whether we're on the device at the edge or on the cloud. So we have here 6 new entity icons. Actually, we have a 7th with the device. But here I wanted just to show you the global shape that we use for all device-related icons. So 7 new device icons. So the device icon, which looks like a box, actually that's what the shapes is referring to. Then we have the service, the resource, then the observation, which is a nice way to combine a magnifying glass and the notion that it's routing the event somewhere. Then we have edge actions. So what we represent here in the middle is always what triggers the action or what is being consumed. So here this looks like curly brackets, which are events. And so that's why we use this shape here for edge actions. Then we have firmware, so it's like the heart of the engine. So it's like a smaller box in the bigger box. And then we have the blueprint. So it's an outline of the device. And then on the cloud side, we have streams, which are series of events, and I think this depicts it quite well. Then we have the tasks. So tasks are periodically executed after a given time lapse. So that's why there's an hourglass. So it's the same idea with edge action and cloud actions. Here we have events that trigger, and here we have a duration that triggers that. And then we have the connectors. And as you can see, the connector is the opposite of the service, basically. So you have it on both ends. Do we have the schema somewhere? Yeah, here. So here you can see how it all relates. So we think it will simplify their, to ease their recognition. And of course, the labels will be there as much as possible in the UI to provide a clear mapping. But the reason why we talk about this is that now we are making these icons available for you to use. You can download a first package with an SVG and PNG version. We will add more formats later, but the idea is to give you material to come up with, to help you build presentations and your own charts that show how your solution integrates with Octave. And of course, they're free to use as long as they're there to present Octave-related presentations and IoT solutions using Sierra Wireless services. Yeah, there's the chart again. All right, so that's for icons. Now I'd like to talk about crypto functions. So here I have, the usual scenario is that you have some data that is generated on the device and you cipher it or you sign it and then you send it to a cloud service. So we have this new library of crypto functions that are now available in Cloud Actions and Tasks. So instead of having to copy paste large functions, they're now available. We choose a library that does not rely on asynchronous computations. Everything is synchronous to make it as simple as possible, as to make its usage as simple as as intuitive as possible. So and the reason is that we currently still use the version 5 of JavaScript, which leaves out some convenient keywords like async and await to deal with asynchronous tasks. So we leave this for future work. But here the solution I was trying to describe goes in the other direction. It goes from a cloud service that wants to send a message to a device in order to control it. And the usual thing when you're dealing with security is that you want to separate things. You want to divide things to scope each entity to a specific set of responsibilities and permissions, so that if one of these entities or server or services are compromised, then the security issue is not too big, so that you don't expose your connected assets, for instance. So here we have a sender that sends a message, and since Octave is now able to easily decrypt and also hash messages, that cloud service can do that. So it can encrypt a command, that's the message that is going to be sent to the device, and it can also sign it by hashing all that and appending that signature to the message. So here we're not sending it right away to the Octave platform. We go through a broker which has no idea of what's in that message, but it knows the hashing algorithm and will ensure that the message comes from a known or trusted sender. And then we go over to the Octave platform. The broker has a very specific, very narrow rights, narrow permissions to write on only one stream, a specific stream. Here we call it stream A. And so in that stream, the encrypted message will be posted. And then a cloud action will decrypt that using the key that the sender used. So the broker has absolutely no idea what's going to be sent. And then that stream is, well, since it's a command, it's a command stream of the device, and then it will send that to the device and update the resource. So again, the broker has no idea about the rest of the solution. It only knows the sender. It only knows how to prove that the message comes from a legit sender, unless the key used to encrypt, to hash the message is out in the open by mistake. But well, at least even if that's the case, then it's not a big issue, because it's still contained, and it knows the specific stream. So when so here I encourage you to check out the groups and permissions features, so you can create a specific account which belongs to a specific group that only has very restricted permissions. In this case, all we need are event write permission on a specific stream, and that's it. And so even though the broker has well, a token and a user, it cannot do any more than just post encrypted messages on that stream.
David?
The sender only knows the broker. Yeah, sorry.
Yeah, one question from Jan. Is there a key vault for certificates and keys?
Well, there's no. So if you're talking about asymmetric, like private and public keys, or
yes, exactly.
Yeah, so no. So the library we're currently using is only for deciphering symmetric with a symmetric password phrase, and yeah, no, there's no, you cannot like read a public or private key to encrypt or decrypt messages. For that, we will have to provide another library. So I continue unless there's a
the question is then do you need to store those passwords, or where would you store the passwords?
Yeah, well, in that case, the sender has to know about the key that is used to encrypt, and the platform has to know the key as well. Okay. But the key does not reside on the broker. The broker only knows while the algorithm needed for computing the hashed version, and any transformation or any message that is appended to it, any token or whatsoever. Yeah, the separation is there. So unless there's another question, yeah. So here the broker knows the sender, knows only the stream it can write to, and the sender only knows the broker, so it doesn't have any credentials. And the broker has no idea about the message that it is going to write, because it's unable to decrypt it. Then on the Octave side, we have a cloud action, and that cloud action should have limited rights to read from the stream the broker is writing to, and it should be able to write to any, in this case, any device command stream. So I don't know if you know that the permissions of a cloud action are based on the permissions of the author of the cloud action. So the trick is, in order to have a cloud action that is restricted, that has these restricted permissions, the idea is to create an account on Octave or to invite someone, and then to add that account to a specific group that only has these permissions. And then with that account, you create that cloud action, and then it will only have these permissions. So this is also another way to prevent any damage in case there is some leakage of keys or credentials. So it's something that we need to expose at some point, is how to handle specific tokens and the permissions associated to it. And of course, it's perfectly normal that you don't know that the cloud action has the permissions of the author, because we don't show that yet in the UI. Okay, so we have all that, and so what I can do is show you a little bit what you can do with Crypto Gis and how you can use the APIs, unless there's another question.
Oh, no other question. Oh, wait, sorry. We actually have questions. So John is asking, yeah, so it's just a feedback about asymmetric keys that feels important, and maybe a good way to connect to other cloud like Amazon Web Services, for instance. So I don't know if that's something you guys are thinking of, yeah, in Octave, maybe for future features, or I don't know.
Well, I suppose, but well, since Augustin is there, I think.
Yeah. Well, it depends on which kind of keys, but with what we enable here, it really makes it easy to push data to AWS S3 or other services that you cannot do before. So this enables a lot of capabilities to push to third-party clouds. Now, with regards to asymmetric keys, or a way to tie more deeply to, I would say, IoT specific components on AWS in particular. So that's these are things which are on our radar screen for the end of the year.
Okay, great. Another question came. Can you create a system type account without an email invite? So I guess so that's related to what David you said, that I mean, to manage the rights, right? So
yeah, so you I know that we have this token system, but I don't know if this, I mean, it's not available in the UI. So but I know the API is there. There's an endpoint to manage that, but I don't know if it's public. Maybe Augustin, you have.
It's public, so these tokens can be used. Now they need to be created through the API, and to start with, you need an actual admin user in the company to use the API to enable those kinds of token. So there's no pure programmatic access. You can't create an Octave account or a company without an email to start with. But once you have that, you can enable programmatic tokens to be enabled.
Okay, yeah, thanks.
Okay, so just as an example, using Crypto Gis, so it's if you guys know about the spec from the W3C regarding cryptographic tools, it's different, and although we like to use standards, the issue was that it was using asynchronous calls. So the functions were returning promises, and then you had to use here .zens and etc. So it was very verbose. So that's why we chose that, and it's also exposed as the exact same name, and you see that in many examples on the web. So you can really just copy paste these examples right there. So here, what I'm doing is I'm encrypting something, some message, which is here in this case a stringification of a JSON object, and I use a key, a secret key. So this is the key that has to be shared in the previous example between the cloud action and the sender. And once we've encrypted that, here we decrypt it right away. And once it's decrypted, so what you should pay attention to is that you have to call the toString method to make sure that well, it's stringified, because these functions usually return objects. And then since we stringified it before, we have to parse it again to get back our object. And so this is a convenient way to store keyed value pairs, encrypt them, and then you decrypt them, and then you get them. So if we run that, here we're on an action. So it's just pick a random event, just run it. And I have an issue, so maybe I forgot something.
This is a real live demo, so it's expected. Issues are expected, right?
But here I failed to stringify. It's oh no, here I'm going to use ES. No, it's still not working. Why? Decrypt.
Jan is suggesting it should be encrypted in the call and value in the result.
Oh yeah, thank you, Jan. No, that's the issue. Totally. Up. Yes. All right. Let's run that. Okay. So let's make it a little bit more interesting and just show that it's well encrypted. Yeah. So you have something, you have no idea what it is, and then you decrypt it. Okay, so as you can see, we have auto-completion. We need to improve our documentation over there. It's not in a great shape, and there's an ongoing effort to make that look better. But in the meantime, we have these auto-completion, so everything is described, and you can use these if you're, I mean, of course, you need to understand a little bit what these different types are. But here we can see that we can use either a string, sorry, or an object to further describe all the options. And then there's the documentation of Crypto Gis, which is very well documented with many examples. So that's for ciphering, deciphering, and I just mention quickly that you also have all the hashing functions, HMAC, all the SHA.
SHA1. So yeah, you just had another question from Romuald asking for SHA1 function to access OVH API, for instance. So I see here that you have SHA1, right?
Yeah. Yeah, 1, 2, 3, and no, it's fairly complete. The only bit missing is the handling of asymmetric encryption and decryption. So these hashing functions and ciphering functions are used, for instance, with AWS. They're on their documentation, they describe in a very straightforward manner how you build the signature of the message you're sending along with the token, it's quite complex. But I mean, it's not difficult. It's just a complex series of concatenations and then a big hash of that. But you should be able to do all that now with this library being available in Cloud Actions, in the tasks, and also in the connectors whenever you want to use dynamic bodies, stuff like that. All right, so that's it for cryptographic functions. Let's talk briefly about 3.2. So I have the privilege to test 3.2 for some time, and here I don't have the final version. It's on another device, but it's basically the same. And what we have now is in the services, we have the possibility to set 2 universal serial parser configuration on either UARTs. And also the new thing on that firmware, so I'm a little bit talking about what's new in 3.2, is that you can set the name of the service that you're using on USP. So before here you couldn't update that. So if you want, you can name that one UART2 and then the other one UART1 if you're into complexification and puzzling people. But you can also give any name. It's similar as for Modbus and the other services. And so what about devices with old configuration? Well, let's see if here we have a new style configuration set up. We have nothing. Oh, because I was fiddling with. Yeah, let's go to D4 maybe. And here, okay. So here we have a new style configuration. I'm not interested in having a new style, so let's check out S2. Do we have? So S2 has an older version. Oh no, it's too old. S3. We are all using the latest and the greatest. Okay, so I guess you have to trust me. If you have a device with an older configuration, because the configuration is different, you can use the UI and it will convert the USP configuration, which previously was set for only 1 UART, and now it will be set for 2 UARTs and it will update automatically. And to update it, of course, you need to you need to change at least something in the configuration and save it in order for it to update it. So that's for the multiple UARTs on USP. Then let's talk about importing devices, for instance. We made a few changes there. So we can now easily switch the columns. So let's say we have here two columns, and then we realize, oh no, this is the name column is actually the display name, and so you can just switch like that. And in case you drop a CSV and you see that it didn't infer the columns correctly, well, you can do so. For instance, here I can switch the name with the AMI, which doesn't make sense, but you can do that. And you can add as many tags and metadata columns that you want. So here you can specify, so here's the metadata. So you can specify the metadata key. And then here you can set the values for each device that you want to import, and you can add as many tags and metadata you want. And you can also remove the columns. It asks for confirmation because, of course, you input a lot of data, and then it's a shame if you remove it by mistake. So that's the improvement for importing multiple devices. And then we also have some improvements regarding the user experience. When you add, for instance, a single device, we now pre-validate the name. So for instance, here, no, it's like this. Come on. Okay, so what's the exact name? No, that's the name. Okay, so for some reason, it is fine with that name. Don't know why. But it should say right away that the name is not available. And the same happens for when you so when you start adding certain numbers in AMI, it tries to at least check the format. And what else? Also, when you create an account, well, the same name validation appears, and it tells you if a name is available or not. So I hope it doesn't do like this here. Oh yeah, because I'm using probably because I'm using a super admin. Yeah, that's my bad. And so what else? We made some improvements regarding the input number. We saw that the input numbers are always different depending on the browser, and some have really nice input numbers with the spinner to increase, decrease it, etc. And some others don't, and some are using Octave on the tablet, and there it's on Android sometimes there is, on iOS there isn't, so it's really cumbersome. So we went ahead and created an input number field so that we have the exact same experience for every user across all the browsers and platforms. And so we have these plus and minus button spinners. And so you can click there, and then you can also use the keys like this. So you don't see me typing on the arrow keys, but up and down does that. And then if you use a modifier key, so for instance, the Alt key, it increases by tenths. If you combine that with the Shift key, so if we go here, sensor, we need an input number. All right, let me widen that a little bit. Okay, so if I use, oops. the shift key here, I get this precision ordering. And also on some software, they provide simple arithmetic to update the value. So for instance, here it's 1.9, and you know you need to add 2.3, then you can do something like that. And then you hit enter, and then it sets that value. Well, here we have a precision issue, but you get the idea. Or I do something like that, and you get that. So it's like the very basic way of updating numbers, and we provide a standard experience for that. What's on the agenda?
Quick question on your why do we convert device names in lowercase?
Why do we convert device names in lowercase? Well, that's the historic constraint on stream paths. Stream paths are like URLs, and we avoid uppercase characters in there. So to make it as simple as possible, it's well, it's a historic design decision, and the idea is to not let users get fooled by weird characters. So we wanted to keep them as simple as possible. I guess that's the motivation. Okay. But then if you want to set special characters, you have the display here. Here you can set whatever. You can use whatever character you want. You can even
that's just for the
emoji.
Exactly.
Yeah.
Okay, thanks.
Okay, so we forbid emojis. Okay, yeah, it's kind of weird, but yeah, but you have a little bit more freedom. You can put spaces and stuff like that in the display name. For instance, can do that.
All right.
All right. I think, yeah, UI team will have to forgive me because I probably omitted a lot of other details that were added, but these were the main ones, I think.
Maybe if we want to keep some time for the questions at the end, maybe we could move to the next part with Augustin now. If that's fine with you?
Sure. Oops.
Okay, so hi again, everyone. And so I'm really happy to present you the new Octave release on the Edge side, so Octave 3.2.0, which has been made available for download on your devices, so FOTA from the platform or the file local update through download via our documentation. Made that available since the beginning of this week. So when this is the main release the Edge team has been working on the last quarter. So quite a few updates. So some things in terms of not seen here in terms of features. So it's at the Linux level. So it's quite a rebase using our latest baseline with security fixes and things like that at the lower level. And then focusing on the Octave level features. So there's a few, I would say, features that stand out, plus a lot of improvements that I'll cover as well, plus bug fixes. So in terms of key features, so one which is more specific for our customers and partners in North America, or for those of you who have projects in North America and US specifically. So we now have FX30 and FX30S available. So we have dedicated SKUs with an enablement on AT&T's LTE-M network, and the FX30 firmware is certified in terms of AT&T modem. And the really nice part, so to keep the same spirit that we have with Octave on all the features we design, is that you just pick that SKU, which is a same hardware, everything, just it's having an AT&T SIM inside, and it has AT&T certified modem, and the platform will automatically download the appropriate firmware to those devices. So when you're deploying a fleet, even if it's mixed between North America and Europe, when you triggered firmware updates, or even use the same blueprint with 3.2.0 attached to those blueprints, the actual proper firmware will be deployed to the appropriate device, and that's done automatically all for you. So really convenient, and really so new feature and new, I would say, SKU and product to have those FX30 certified in the US. Now, in terms of functionalities at the Octave level, so David covered the part and showed the UI that now USP, so generic service to interface serial devices to Octave, to Octave. So using USB, this can now run simultaneously on both UARTs. So we have a few customers already using that and having used that on the preview, and this works really well. So David showed the UI part, but from an edge firmware perspective, what the feature we brought is to enable this capability. And something we also updated, it's USB support on the WP77, meaning it was already implemented, but the WP77, so standalone module, had in the previous version, it in 3.1, it has some auto suspend feature on the UART to save power drain. So this will in some cases interrupt, or will need to have some wake up frames from the USB client to get things going through. So now we can disable auto suspend, so you can have a USB working flawlessly on WP77. And one other big change on the ORP side, so whether in a generic fashion, whether you're using it on the WP, on the FX30, or on the Mangos, the ORP now allows access to all other Octave resources, meaning before ORP, so which is the Southband API or interface to connect an external controller to the Octave device. It originally only had access to the ORP set of resources, so specific namespace and just typically resources used for configuration inputs and outputs. So if you wanted to control some Octave components, enabling another sensor or accessing an Octave resource, you had to chain observations to pipe the ORP to the Octave resources, or the other way around. Now from ORP, you have full access to all Octave resources, which makes it really easy and simple to control everything that you can do on the Octave edge side directly from an external controller using ORP. So next slide, please, David. Yeah. So here's an extract and comment here. So you'll find the full release notes in the Octave UI. So in the what's new and alongside with the firmwares. Here I just did a selection to highlight the key ones. So in terms of feature enhancements, so changes or enhancements to existing features. So on the Modbus side, a small change is that now when we write to a Modbus asset, we now use the single register write when you just write one word, and use the multiple write when you use more words. We used to use the multiple writes in any case, even with just one word. It works on most Modbus assets, but some like to use single register write for just writing one register. So the behavior is now this one. So enhancing the compatibility with a set of Modbus devices that are out there. One other key change is that we're making it easier to start enabling some logic on the edge side once all the Octave services are up and running. So in 3.1 or before, a typical way to do that would be to enable a counter and wait for the counter to have reached, say, certain amount of seconds just to make sure that everything is started, but didn't have a real way to know that everything was up and running explicitly. So now the cloud interface config received value is now triggered. So when there's a configuration change sent to the device, or when it starts up, it triggers once all the Octave services have been configured and are enabled. So this gives you a good starting point to start running any kind of logic on the edge side once everything is initialized and is properly running. On the watchdog side, so a small detail, but it can now be disabled by setting it to a 0 value. On the UARTs, we have increased the compatible speeds. I don't recall which was how far it was limited before, but now we really enable the full speed that is available on the module, and so it's well, you see the figure, can't read the exact number, but higher baud rate for sure. Now, with regards to the Energia IoT cards and their add-ons, so before it was supported in 3.1, but in that case you needed to enable it by a local command on the device, so SSH on the device and set a flag once to enable the service. Now it will automatically start. The service will start if it detects the presence of an Energia IoT card in the IoT card slot. So that's done automatically. And on the CAN-open front, we now support extended frame format. So we have some customers who had been asking that for some time, and it's now fully available. And so that's just maybe a 1/3 or half of the enhancements that we have brought. So I let you direct you to the release notes to have a full view on what's new in terms of small changes on features.
And by the way, thank you guys for all your comments and your suggestions of improvements. This is how the team prioritize all these adjustments, enhancements, and so on. So that's great. Augustin, one question maybe regarding IoT cards. Here you are talking about a specific one. Are we planning to enable this kind of presence or the detection of IoT cards for other IoT cards in the future?
So there are other IoT cards. So there are different things. There are IoT cards which don't require specific drivers. So typically converters, standalone hardware converters. So the Octave device are fully compatible with all these sets of cards. Now, with regards to having some with drivers, so definitely enabling a new set of, I would say, cards or sensors. Yeah, definitely in the pipe at the Octave level. Will it be through automatic present detection of some cards? Not necessarily, but yeah, the topic is really it's one of the high priority topics on our plate, and yeah, you'll hear from us soon on that topic.
Fantastic, thanks. And maybe we can say to you watching this, if you are a provider of IoT cards, I know some of you guys are quite active in around IoT cards in the Mango developer community and so on. Feel free to reach out to the Octave team so that we can best integrate those IoT cards. Thanks.
So next slide, please, David.
Just a quick question for you, Augustin. Does the inability to regress from 3.2 to 3.1 firmware apply to both local and FOTA downloads?
Yeah, so I'll cover that. It's the last slide. I'll come back to this.
Okay, thanks.
So yeah, once again, an extract on bug fixes and improvements. So I won't necessarily cover all of them one by one here, but yeah, it's on bug fixes or stability improvements. One, maybe just to highlight one. So yeah, which change, if you notice some changes in the signal bars that you see in the Octave UI, we're now aligned with I would say smartphone industry standards, which was not the case before. So used to show pretty low bars for, I would say, average signal. So it could sometimes was worrying even if the device was in, I would say, average, still correct conditions. So now you will see slightly higher bars for the same amount of signals. Now, yeah, a lot of, I would say, improvements or fixes on things that happen in specific case. So with VRs, with some action runner cases. One improvement in terms of performance for Modbus users. So if the system tries to read a register, only you read hundreds of register on a single device. If it times out on the first register, meaning that the Modbus device does not even respond, then rather than trying all 100 of them and having 100 millisecond timeout each, so waiting a lot of time at the end before going back and even trying to pull another Modbus asset, which might be there now on a given timeout from a given asset, we won't try to reread any register until the next global cycle to optimize things when you have multiple Modbus assets and one is offline. So that's a really good improvement for those using a lot of Modbus assets. There are fixes in some rare occasions, and happened a bit more in North America than in Europe. But definitely in 3.2, there are some stability fixes and robustness fixes and improvements. Where in some rare issues, it was difficult for the device to connect back rapidly after network loss or after a power cycle. So a lot of improvements on 3.2 on that front. So from that perspective, on the long run, anyone who's ready to transition their fleet to 3.2.0 once things are qualified from a use case perspective, we definitely recommend using 3.2.0. And then fixes on specific case on ULPM where network supported PSM, and some issues where the math random values were not random every time. So now that's fixed. And maybe to leave a few minutes for questions. Just next slide. So one important notice is that, as mentioned, so on the FX30, so this is FX30 only, meaning on the Mangos or on the WP77, we don't have this specific notice. And so here, once upgraded to 3.2.0, an FX30 must not be downgraded to an earlier version. This is related to the way the credentials are stored locally. So there's a one-way operation and one-way migration, which is done. And so if you try to launch it, the downgrade will happen. The device will even continue working in 3.1. Now, if you go back to 3.2 or try to go back and forth, you will end up having issues. So the notice is that this once in 3.2, you must not downgrade to 3.1. So the UI and the API, or even if you apply a blueprint which has 3.1 tied to it, to a device which is on 3.2, the system will prevent you from doing this. So it will actually not send 3.1 to an FX30 in 3.2. Now, to answer the question on local update, nothing prevents you to do the update to ask to locally put the device in 3.1. So nothing will stop you from doing it, but that should not be done in any case. So you will fall in the same issues. So that's why it's key not to do it even locally.
So Andrew, you have your answer. Thanks, Augustin.
Thank you.
Thank you very much. Is there any questions either related to the multiple topics for today, or any other question you would like to ask to Augustin or David? Please do it now. In any case, this slide just to remember that to remind you, sorry, that the whole Octave team is very active and support you on the forum.tirewireless.com/c/Octave, and so is there any more question? No, I don't see. I don't see any other questions. So I think it's time to wrap up this session. That was the last session before our summer vacation, because we are in the north hemisphere here. So we'll get back. So we'll skip August, and we'll come back with you in September, the 10th of September exactly. You have here my email address once again, whether you are an IoT card provider, you want to interact with us, or if you have a IoT application use case you would like to share with the community, share with us and the community, give it a bit of promotion, we are really open to that, and see how you use Octave for your specific use case. So feel free to reach out to us. You have my email. You can reach out to us with Twitter as well. Follow us on Twitter, obviously. If you are watching this not live but on YouTube, please register for the next sessions in September. And in any case, do subscribe to our CR Wireless YouTube channel, because as you saw, we have Octave tutorials, we have these sessions on Octave, and maybe more in the future, who knows. All right, a lot of thank you in the chat. Thank you guys, thank you for joining. Great presentation, said Sudhir. Thanks, Sudhir. Thanks, Ian, Romuald, thank you. Thank you all guys for your interactions. That's always a pleasure. And see you in September. Thank you, David, and thank you, Augustin.
Thank you, Thibaut. Thank you, everyone. Goodbye.
Thank you, guys.
Bye-bye, everyone.
Bye.